Welcome to the online lab session for Lab 1, specifically for Group A. Yeah, so if you're not in Group A, you don't need to watch this. If you're in Group A, you need to watch this. This is our online lab for Lab 1. Yeah, something I would have liked to have met with you guys in like the virtual lab class last week in week 1, but I was just not able to. And you know what, Lab 1's pretty simple, so I can just do it just like this. So what I'm going to do is I'm going to walk you through Lab 1. Let's just take a look at the schedule, and then I'm going to walk you through Lab 1 and tell you like what it's going to look like, what's going to be going on, how you find it, what do you do when you're there, all the rest of it. So let's just talk about scheduling. Okay, good. So I've got this crazy schedule that I made. Actually, I've only opened up a few of my calendars that I have here. So I've got all the A sections for Introduction to Controls. So right now, all of the A sections are up on this calendar. So if you're in, because we're all in Group A, if you're in section AB, then it will be on your schedule that you have a class on Monday at 4:15. If you're in section AA, it will tell you you have a class for this course on Wednesday that is not the lecture. And if you're in Group AC on your schedule, somewhere it will say you have a class for this course on Wednesday at 3:20, and if you're in MA, you will see on your schedule you'll have a class for this course in MA. And then if you're in Electromech, most of the guys in Electromech, they're having their lecture here at 3:20 on Tuesday, and most of the guys in Mechanical are having their lecture here Friday at 8. If you want to come to either lecture, I'm perfectly fine with that, dude. I'm going to cover the same material. So with that said and done, you know that if you're in Group A, this in week 2, you have to go physically into school and go to lab. Whatever your schedule says, either it says Monday or Wednesday, that's when you physically go to the lab. So from there, what we're going to do right now is we're going to actually jump into what the lab looks like. So let me jump onto Blackboard. Here we go. So go into Blackboard. Go into it because we're in A. I'm going to go into section A. I should actually call that Group A. I'm going to change the name. So here we go. Now I'm in Group A, and we know the calendar. You guys know you're in lab next week. You guys know that because you watched this video already. And then go into Lab 1. Here's Lab 1. Bam. So Lab 1 looks like this. Now watch this video. Like, I mean, I'm just going to open it up. We're not going to watch it because I'm assuming you watched it already. But, you know, it's me in the lab hooking this stuff up.
Hit this guy over here, and that shows a little beep, and that's
Is that what does
continuity.
it? Yeah. So just watch this. You have to watch this video because you have to be familiar with all of these things. And have this video, let me talk to you about what the lab's going to look like. So what you need to do first before you go into class this week is you need to actually read all of this. We'll read it together. So we're in the lab class together. It's the virtual lab class. So let's read the lab. So what you're going to study in the lab is you're going to study measurement. You're going to hook up a basic circuit. We're going to add a little control. Like I said, the theme of control, I'm just going to throw it into everything we do. So in this particular lab, we're actually going to study control. We're going to study measurements, so I want to get you guys familiar with the measurements. Now, if you don't know how to hook up a circuit and what Ohm's law is, it's okay. If you don't know what a resistor is, it's okay. You know what a switch is. So just follow all of this. It's not that complicated. There's one calculation you have to do, which is really simple. So let's just go through this. So what you're going to do is this is the actual lab. You don't have to print this lab out. You do not have to print it. And I'd rather if you didn't print it. Actually, if you can print it out and bring it to class if you want, but just don't give it to anybody. And that's cool. So lab 1, and then you're going to go into class, and this is the stuff you're going to get. You're going to go and get 3 of these. You're going to go and get one of those, and you're going to go and get one of these. That's it. So go in, get 3 switches. Go and get 1 bank of resistors and go and get 1 motor. So remember that. Actually, maybe you should even print out this first sheet so you know. So have that information available because you should be going and getting your equipment while your computer is booting up. Yeah. First thing you're going to do is you're going to walk into the class and you're going to turn your computer on. That's the first thing you do because it takes like 10 minutes for the stupid thing to boot up. So while it's booting up, go get this equipment. Probably take a while to get the equipment because we're gonna like social distance and all that, and you know the equipment drawers are usually like have students like fighting, like get out of my way. You can't do that. Okay, so So, and then this is about resistance measurements. So, dude, you're going to follow this procedure. You're going to press these buttons, and you're going to, because you've watched my video, you know how to do it. And then you're just going to take the measurements and write them down here. You have to put decimal numbers in there. The reason is because this is actually like a test on Blackboard, and for you to get the marks, you have to put a number in, and I can't identify what the number is going to be. So I just said, as long as your value includes a decimal, you get it right. Anyway, so there you go. And there's this question here. Type in yes or no. It's actually a really simple question. And then, do resistors have polarity? You know what? Just watch the video and you'll find out if they do. And you write these values down. So you're gonna measure the resistors the other way around. So you measure a resistor like this, and it gives you a value. And then you just take the probes off and you switch the polarity of the probes and you kick it on the other way, and then you take the measurement. And you're gonna see if it's different or not. Yeah, so you're going to study. And I did that in the video, so you know the answer already. Check for continuity. Beep, 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 beep. You're going to check for continuousness. Yeah, it's pretty cool. That's kind of a word I made up, but it's real for me. So I don't even know if it's real or not, but it just means a continuous connection. I explained it in the video, so watch the video. And you're going to check. You're going to be like, beep, 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 beep. Does this work? You're going to check the switch, turn it on and off, and go through continuity and make sure you understand how to use the continuity setting on the DMM. And then you're going to measure voltage. So you're going to hook up circuit up, which is pretty cool. You're going to hook up this circuit. Let's just zoom in. Dude, you're going to hook up that circuit. It's really complicated. No, it's not. And you'll see how I did it in the lab. I actually hooked up the components the way that the circuit is. So when you're hooking the components up, place them on the board the way that you see them in the actual circuit. Do that with a breadboard too, if you use breadboards. We're not going to be using breadboards in this. And if you don't know what a breadboard is, it's okay. You're going to find out. So you can Google it. What's a breadboard? Does it have to do with bread? I'm not hungry. Yeah, kind of like that. So, yeah, hook the components up and follow. The wires are right here. I'm showing you how to do it. I've actually built the circuit right there. And then you're going to take some measurements. You're going to use the DMM, and you're going to take measurements. You're going to measure the potential voltage of the actual source itself. That's the potential voltage. Yeah, dude, we're going to study all of this in lecture. Just roll with it. The potential voltage and the voltage drops are different. We will definitely get into that in lecture. But right now, I'm just saying the potential voltage is the voltage that's coming from the source. The voltage drops are the voltage that we lose across the components or the loads in the circuit. So here we go. So use the DMM to measure and record the potential voltage from the source. Just right there and write it down here. I don't think you can write 4 digits. Maybe, yeah, I know you can. It'll give you 4 digits. 4 decimals. I don't think it'll give you 4 decimals. Doesn't matter. Just make sure you add a decimal or you won't get the question right. Yeah, you're going to do all of this on the computer. You will not be writing this down on paper. Okay, cool. Down here, it says 4 decimals. I have to change that. I don't think it should be 4 decimals. It should be like maybe 2. Doesn't matter. You have to put a decimal place. Actually, you know what? If you just actually, this is inside. If you just actually hit a decimal, that's all, and hit enter, you'll get it right. But I want you to put numbers there. So yeah, you're going to measure the voltage across the resistor. So in this circuit, you're going to measure the voltage across that resistor, or the voltage that we're losing across that resistor. You're going to measure the voltage across that. Just put the probe on either side of the resistor. And then you're going to put the probes in the little banana clips across the motor, and it'll tell you the voltage of the motor. So that's all you got to do. Okay, so and then you're going to short out the resistors. Right, this is kind of cool. This is control. You're going to take a wire and you're going to short out the resistors. When we talk about is a short is where a wire kind of crosses the whole resistor. So the current's not forced to go through the resistor. It jumps across the wire. It doesn't even go through the resistor. The current doesn't go through the resistor. It's shorted by this wire. So that actually changes the total resistance in the circuit, and you'll see that the motor speeds up. So you're going to do that, and then you're going to make another short, and you're going to answer these questions. So, dude, make sure you read all of this stuff before you go, and you'll read it in the lab as well. So the experiment shows the speed of the motor. So you're going to control the motor by actually shorting out the resistors. And the reason the motor is speeding up is because the resistors are stealing some of the voltage. If you just take the resistor right out of the picture and short it out, then that resistor is not stealing any voltage, and the motor gets it. Yeah, so the motor goes faster. So, and then there's this cool question by adding switches. So essentially what's going on is I talked about that a little bit. Actually, I did one in the lab. I showed an example, but like all I'm doing is let's go to this one. I'm shorting out this resistor with a wire. Well, I can actually use 2 wires and go over to a switch and then change the switch on and off. So I can kind of like add control, and I'm controlling the speed of the motor by flipping a switch. That's pretty cool. So I could do that, but I could also do that for the other resistor. So, I mean, I've got resistor 1, that's 100 ohms, and resistor 2, that's 200 ohms. So I can actually put 2 switches in there. Oh, that's pretty cool. So, I can use one switch to short out resistor 1 or not short out resistor 1, and another switch to short out or not short out resistor 2. So my question here is, well, I mean, how many speeds will that give you in the motor, right? Not including off. Like, so the answer here, I mean, you have to actually get that right. If you answer the wrong number, you get this whole question wrong. It's kind of mean. Okay, wait. This whole question here, which question is it? Anyway, this voltage measurement control. So think about it. There you go. And if you want, you can ask your instructor, right? And he'll guide you through. He'll be like, he'll actually look at you and go, I don't know, think about it. Right? Or try it. Hook it up and try it. How many speeds can you get? Question, which reading is more accurate? The reading from the power supply or the reading from the DMM? So if we actually look at the power supply, and which is right over here, we look at that guy. See that guy? You've got 2 decimals. You've got 24.00, okay? This guy will give you 3 decimals. So which is more accurate? I don't know. Yeah, that's the question. And then reverse polarity connection of the motor. Right. So what's going on is that DC motors will reverse their direction and spin when their polarity is switched. So yeah, like motors, DC motors are polarity sensitive. It means when you hook them up, when you hook the polarity up a different way, they do something else. What happens when you hook up resistors the opposite way? Do they do something else? Well, if they do, it means they're polarity sensitive. If they don't do anything else, they just act the same, they're not polarity sensitive. So there you go, current measurement. Now this is where we get a little bit funky. What you're going to do is this. This is pretty cool. You have to understand that when we're measuring current, you have to break the meter. Yeah, and we'll talk about that more definitely in week 3. We'll unpack that like in depth. For now, just roll with this. Just hook up this circuit. Yeah, put the meter in the circuit. So, and you have to actually reconnect the meter a certain way. You have to, did I mention you have to watch that video? Yeah, you won't be able to do it unless you watch the video. And make sure the video is up and ready to go. Like, actually, when you open up your computer, start the actual lab itself, also click on the video, open it up so you can scan through it and watch me do it. So in the lab you can be like, how did you hook the meter up again? And just scan it, pause, whatever. Oh, you did that. Okay, click play. What back up? Oh, that's how you do it, right? So I explain it why you have to do this in the video. It's important that you watch the video. So then you're going to record this. Now the meter itself, let me go back up to a picture of the meter over here. The meter itself, okay, so this meter is reading millivolts DC. It's set in millivolts. The number that's on there is in millivolts. I mean, if I had 200 millivolts, it's 0.2 volts. But that thing, if it's reading millivolts, it'll say 200. It won't say 0.2. So my point here is that milliamps is kind of the same thing. The meter, whatever the meter is reading, it will actually give you milliamps. But how much is that? There we go. So yeah, record the reading of the meter in milliamps. So you, like, just put the number in the meter right there, and that number is milliamps. I've already put the unit here for you. So what we're going to do is we're going to calculate. So it's pretty cool. Motors, they change their resistance depending on their situation, actually. Light bulbs do that too, to some degree too. Like an incandescent light bulb, when you measure the resistance of an incandescent light bulb, the resistance will be a lot less than when you heat it up. When you heat it up, its resistance goes up a lot. So when you turn it on, its resistance shoots up. But if it's cold, the resistance is different. So often things change the nature of their resistance, whatever resistance is. I mean, we will talk about what resistance is next week in lecture. But just roll with it now. Resistance is the resistance to current. It's like it says, no, I'm going to slow you down. I'm going to resist the current. That's resistance. So what's going on is that if a motor is just sitting there and you measure the resistance, you'll get a value. And then if you run the motor, that resistance value will change. I want you to discover and like experiment to see how it changes. Does it go up? Does it go down? What happens, right? So you want to just measure the resistance just like you did the resistors. of the motor. When we measure things, when we measure the resistance of things, they cannot be connected to anything. We have to actually physically disconnect them. So physically disconnect the motor. Oh, did I say that? Yeah. You have to physically, like, take the wires out of the magnetic plugs in the motor. Like, it shouldn't be hooked up to anything. Actually, the resistors shouldn't be hooked up to anything. Anything you measure of resistance shouldn't be connected to anything else. So disconnect the wires from the motor, stick the probes in there, set the DMM to read resistance, and write the value down. Write it down here. Make sure, calculate. So you've already, somewhere else you measured it. I don't know where it is. Here it is here. So the motor, you've already measured the resistance of the motor here. So you know what the value is. Now what you're going to do is you can't measure. This is cool. You cannot measure the dynamic resistance of the motor because you can only measure resistance when it's not hooked up to anything. And you can't study the dynamic resistance of the motor because it has to be running to do that. And the fact that it's running means it's hooked up to something. I think you get that. I won't say that again, but you can play that again if you need. But essentially, we can't hook the DMM up to the motor when it's running because it's hooked up to something. So what's going on is that we have to calculate the resistance. To do that, we have Ohm's law, which we will go into. It's really cool. Just believe me for now, Ohm's law is this formula. It's a really complicated formula. It's voltage. Yeah, take a look at it. It's voltage divided by current. It's right on the screen there, right there. So you're going to take voltage and you're going to divide it by current. Hey, what's the voltage across the motor? What's the voltage drop across the motor? That's what you need to do because you're studying the motor, right? So you have to study the nature of its voltage, the voltage that's dropping across it, and also the current that's going through it. Well, we know the current going through it because it's right here. You've just measured it because this meter is telling you the current that's going through the meter. So you have a value for the current and you have a value for the voltage. Now, this is important that we do this together. So just pause for a second. Let's say the voltage in the motor is 5 volts. Okay, so I'm going to type in a 5. Done. Now, what was the current going through the motor? Well, let's say the current going through the motor is 47 milliamps. Let's say it is. I don't know what it's going to be, but let's say it's 47 milliamps. I think I forget. But in the video, you saw me measure it, and it was some value. Let's say it's 47 milliamps. So I'm going to type in 47. Okay, here we go. What's that answer? Yeah, look at the answer there. Okay, the answer says 106 times 10 to the minus 3. So that's 0.106. But we're measuring ohms, right? So 0.106 ohms. But the thing is, dude, that's not right. That's not a right value. We always, resistance will always be more than 1. Well, it's pretty rare that it's less than 1. It's pretty rare that it is 1 or even that it's less than 10. That's pretty rare. So what you need to do is you need to actually put in the milliamps, okay? So watch this. 5 divided by. Now, if it's 47 milliamps, you have 2 ways to do that. On my calculator, I use engineering notation. I type in 4, 7, and then I hit this guy, and then I go for my double E. Where's that double E? Reminds me of a... It's hard. I'm looking at my calculator in a weird angle, and I don't know where anything is. It's that double E there. Reminds me of a Bob Dylan song. So double, and then I hit enter. There you go. And it. Oh, I don't know what happened. 5 divided by 47. E. Okay. So E. Oh yeah, I forgot. I have to hit the component. Minus 3. E to the minus 3. And the reason it's to the minus 3. There you go. That's 106 ohms. So the measurement, the resistance there is 106 ohms. Now, I'm not sure what the current was. I think I got that wrong. I don't think it's 47 milliamps, but it's some value around there. It's 22 milliamps or something like that. So what I did was I typed in 5 because the voltage drop across the motor is 5 because I measured it to be 5 in my head doing a thought experiment, right? Whatever the voltage was that you measured in the voltage step, use that value. And then whatever the current is here, you got to type it in. Now, like I said, you can do it that way. So let's just say it's 47. You can type 5 divided by 47 and then use that E symbol. I think some of you guys maybe have a 10 to the X on your calculator. And then I'm going to say minus 3, which means milli, which we'll talk about in lecture this week, but just believe me with that. The other way to do it is this. 5 divided by 0.47, and you see, it gives you the same number. 5 divided by 0.7 gives you the same number, because 47 milliamps is 0.07 amps. No, I just lied to you. 47 milliamps is 0.047 amps. 0.047 amps. So however it is, if you want to calculate the resistance, you have to physically put in like a decimal. In this calculation, whatever, you have to put a decimal here, or you have to use engineering notation. One or the other. You can't just type in 5 divided by 47. You can't do that. It's not allowed. So, so move forward there. So make sure you do that calculation, right? And when you put your when you put the value in here, make sure that there's at least one decimal, because I need that decimal in there. Because if you put like 43 in there, or 62 in there, or 12, you'll get it wrong. Even if your calculator says exactly that, you'll still get it wrong. You need to put a decimal. Your calculator is not going to say exactly some number. It'll have a decimal. Put at least one of them in there, because you need that point, or you'll get that wrong. Okay, leave the I'm hooked up. Read the right. Okay, so and then the other thing is short. Make a short of resistor 1, and you'll see the current will change. The current, well, you just check it out. If the motor goes up, does the current go up or go down? I don't know. You'll study that, right? So here the discussion, blah, blah, blah. What is this? Yeah, this is really cool. So the static resistance motor is less than the dynamic resistance. I gave it away. This is because the generation of magnetic field decreases with the equivalent to this is Lenz's law. Yeah, Lenz's law. Dude, go watch that video on Lenz's law. It's in Lars. It is in Lars Explains. It's really cool. If you want to know about Lenz's law, it's really cool. We'll talk about it in depth. But the motor is moving. Yeah, okay, so it's cool. So because of Lenz's law, we have this thing. It's kind of resistance. It's not actually reactance either, but it's kind of like a mix between the two. It has to do with Lenz's law. I mean, Lenz's law, reactance won't exist without Lenz's law, and whatever. Maybe you don't know what I'm talking about, and that's fine. It's okay. What we're doing, studying here, is we're just noticing that if you put a load on the motor, the current changes. If you put a load on the motor, well, if the current's changing, it means the resistance is changing. And the reason is because if we just go back to Ohm's law, resistance is voltage divided by current. So if I change the current, the voltage drop, and by the way, the voltage drop across the motor won't change very much. It will actually change to some degree, but it won't change very much. And the voltage won't change very much, but the current will change a lot. So what's going on, actually they'll both change, but it'll be more the current. So what's going on is that you're going to pinch the motor, and you'll see me do it. You'll actually see me, when you see the video, you'll be like, oh yeah, it changes a lot. It's pretty cool. So as you pinch the motor, you'll see. So there are two things going on. When you actually short one of the wires, you'll see the motor speed goes up, and the current will actually go up as well. So, and when you pinch the motor, the current will change as well. That's because the resistance decreases. Yeah, think about it. Resistance and the current will go up because current and resistance are inversely proportional. So if you change one, the other will change inversely, which is pretty cool. So we're studying all this stuff. Like, it'll be cool. When you hook all this stuff up, you'll be like, I can see how things are like related to each other. So which is higher, the static resistance or the one you calculated? So whatever. The answer is static or dynamic. Write that word in or that word in, and you'll get that right or wrong. But if you write any other word in there, you just get it wrong. Okay, so investigation. So you're going to actually slow the motor down. You're going to pinch the motor. You can actually stop the motor and stall it. It's not that strong. And you can stall it and see what happens. Don't do it very long because it's not good for the motor. But yeah, you can like, but don't like hold on to it because it'll heat up and then it'll just die. But yeah, you play around with that and you'll see that the resistance changes. And sorry, that the current changes because of the resistance changing. Because again, resistance we'll study resistance a little bit more in lecture, but resistance isn't just, the resistance to current is bigger than just the word resistance. That's pretty cool. We'll look into that a little bit more. So, and then that's it. So that's the lab. We just went over the lab. You have a good idea of what you're going to be studying when you go into the lab, and you get that. So now I want to tell you what the experience of physically going into the lab looks like. When you physically go into the lab, turn your computer on and then go in here. This will open up for you. So if you're in section AA, And whenever your class is, it will open up. If you're in section, you can't see all of these. Like right now, if you go there, these won't be here. They will only open up for you during your lab class. So they will open up for you right as soon as your lab class starts, and they will disappear after your lab class. Actually, I set them for 5 minutes after. So whatever. So if something's going on and you need an extra 2 minutes, it'll still be there, but it'll auto submit at the end. So what you're going to do is you're going to click on this, and it's just like a quiz. Okay. So you hit continue. Yeah. Okay. That's good. I have these components. You can get that component, that component, that component. You're going to actually have these components before this quiz even starts, because by the time your computer stops booting up, you'll have these components on your bench. By the way, the wires are at your bench. You're going to hit continue, just like a quiz. And then you're going to go in here and you're going to be like, okay, this is good. You've already read this, and you're going to take some measurements. Watch this. I'm going to take a measurement. So 100 ohms, I'm going to say it's 97.6. This guy, 200 ohms, it's going to be 201.5. Now I say 2 decimals. Yeah, I said 2 decimals in here. I changed it. 1 decimal is fine as well. I just need you to put that period. Actually, it's good to write 2 decimals, because when you're actually in the lab taking measurements, you want to get as many as you can. If there are 3 decimals, write them down. So 400, let's say that's 397.962. Okay, that's what the meter said. I don't know. Actually, it may not say that. I think you'll get at least, I know you'll get at least 2 decimals. Write all the decimals down that you can get. So this is 802.34, whatever, and then just continue. So are the measures exactly the same as the nominal value? The nominal value is the value written physically on the resistor. So is this exactly the same as 100? Let's put yes. Yeah. It's just like, but no. So they're not exactly the same. And that's kind of the point of this question. Is like, dude, the nominal value, the actual reading you get of the resistor will never be what it's actually written on it. No. And we'll study that in lecture. So, and when you flip these around, so just write these numbers in. Whatever, remeasure these, and whatever the numbers are, write them down. And by the way, when we look for trends to see if something is true or not, we look for consistency. So we may want to say that it's really close. Maybe not exactly, but if you get consistent numbers that are really, really close to the other consistent numbers, then you can say that they're the same. So check for continuity. You're going to go beep, 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 whatever, and then you're going to answer this question. So so why would I check for continuousness? Like, does this beep, beep, beep? How does it help me? Does it help me checking to see if a fuse is blown? Oh, yeah, I could take a fuse and check it. Beep, beep, beep. Oh, it's not blown. Okay, I could do that. So it's that's the answer there. Checking fuse is blown. That's the one. Well, maybe let's check the rest of them anyway. Diagnosing a faulty circuit. Oh yeah, dude, I do that all the time. And I use DMM continuity, so I know that's the right answer. But no, but let's just check more. Okay, checking to see if an incandescent bulb is blown. Oh yeah, because if it's blown, it won't have continuity. Oh yeah, you could do that too. Anyway, you just keep reading. Okay, so voltage measurement and control. So you're going to do the voltage here. You can hook up. If you can't hook, look, you know what? If you hook up this circuit and you close that, either your circuit's not hooked up, something wrong with one of your wires, or, are you ready for this? That guy, you didn't turn it on. Right? Other than that, these components don't die. The resistors don't die, the motors don't die, the switches don't break. So it's either a wire that's not right, or you just didn't hook it up right, or you didn't turn the power supply on. So I don't think you'll have a problem hooking this up. I mean, just take this picture and just do it. You'll be fine. And then measure the values and make sure it says 4 decimals. I don't think you'll get 4. So whatever the value is, just write it down. So the voltage drop here, it could be 2.37. I don't know, right? But you have to put a decimal. Actually, again, like I told you, like if you put a decimal here and a decimal here and a decimal here, you'll actually get those questions right. Yeah. But don't tell anyone about that. Okay. So, and then you're going to play around with the shorts. So this circuit's running already, right? The circuit's running already. By the way, when I built the circuit, I didn't put the switch in. I shouldn't have even put that picture there. I'm bad. So I just forgot. Okay, so deal with it. Put the switch in there, right? Short the circuit and then see what happens. And then answer this question. Just type in the blah, blah, blah. So the answers are here. So not including off. How many? Blah, 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 blah. The answers here. And these are the answers here. Most significant. Wait, right. Power supply or DMM. You're going to write power supply or you're going to write DMM. You write anything else in here, you'll get it wrong. So here we go. And then again, you're going to take a measurement. You're going to write it down. You're going to take a measurement. You're going to write it down. So you're going to do all of these things and write all of these things down. And you're going to write all of this stuff. And then you're going to hit submit. And you have to do that before you say, yep, I'm going to submit it. Let's see what my marks are. Let's see what I got. Let's see what I got. I got 5 out of 30. Oh, yes, because I didn't answer them. But, okay, so you know the experience of what it's like. And that's your lab. You're done. When you're done this, pack it up, put it all away, and then clean up your station. So when you walk into the lab, you'll actually have to physically clean all of the material. You have to physically clean the counter. Everything where you touch, you have to clean it. Clean the wires, all the components, everything. And the bench. And when you put the components away, clean them before you put them away. Does that make sense? Just do it anyway. Clean them before you put them away, and then leave. That's it. Walk in, clean, do your lab. Walk in, clean everything, grab your equipment, clean your equipment, do your lab, clean the equipment, put it away, clean your station, and leave. Yeah, pretty serious. So that's what's gonna, and then this is just a quiz while you're there in the actual lab. So just do that, and your instructor will be there, Narain or Ken will be there, and they will be helping you out with this. They'll also be going through the lab, like they'll have the lab open as well on their screen, and they'll have like they'll open up the quiz on their screen, and they'll just go through it. And if you have any questions, they will talk to you through like a video conferencing thing. They don't even have to come to your bench. And I do believe that the lab instructors will want to come over and see your circuit working and sign off that your circuit's working and that you've built it properly. So they'll physically be with you, like 6 feet away, looking at your circuit, saying, "Hey, you know what? Try this, try that, whatever." If you don't get it working, so that's it, dude. So see you next week. No, see you the week after when we go to the pre-lab for Lab 2. You guys are good for Lab 1. If you have any questions, email me, and it was good hanging out with you. Oh, goodbye. Where's the button? Huh, there it is. Oh, goodbye.